All right, this is going to be the by hand version of the last 4 problems of the Math 110 final review. Number 69, actually, you have to do with your calculator. It says you solve the system of equations using your calculator, approximate the solutions. All right, so we've got 3x, here I wrote them down here, 3x minus 2y equals 6, and y equals log base 10. Of course, the common log, we don't write the base, but it's assumed to be 10 when it's not written, of x plus 3. So the graphs are basically a line. This line, you could see the x-intercept. If you plug in 0 for y, you're going to get 3x equals 6, so x is 2. And if you plug in 0 for x, you get the y-intercept. Plugging in 0 for x, negative 2y equals 6, and y is negative 3. All right, because basically, plugging in 0 for y makes that term go away. So you can see x has to be 2, and plugging in 0 for x makes that term go away, and so you can see that y has to be negative 3. So you can plot those, 2, 0, and 0, negative 3, right there. And so that line looks like that. All right, this logarithm has a asymptote. This is basically a shift to the left 3, and your log base 10 has an asymptote that's at the y-axis when there's no shift. So this one has an asymptote at negative 3. Otherwise, it had an x-intercept at 1 that gets moved over to right there. Basically, if you plug in negative 2 here, you'll get log of 1, which is 0. What power of 10 gives you 1? The 0 power. And other than that, you've got this very close to horizontal. It continues going up, but very close to horizontal, and then something that gets really close to its asymptote really fast, but then continues on along its asymptote, getting closer and closer and closer. So there's actually 2 intersection points here, and we were able to find this one pretty easily because the calculator can graph this part of the graph that's not close to horizontal. The calculator has a hard time graphing this part that's horizontal because it's just plotting points from left to right. So it finds values of x, and it comes upon a value of x, a point on the graph right here. It doesn't even see these down here, but they do exist. And I was able to find that. I'll show you. But this is the intersection point that's more obvious, and the only way to find it is to use your calculator, because I mentioned this on the other video. If you tried substitution, you'd have an equation that has 3x minus 2 log of x plus 3 equals 6. And if you remember how you solve logarithmic equations, you would get the log by itself, and you'd have equals 6 minus 3x. And then you divide both sides by negative 2. And you'd have log of x plus 3 equals negative 3 plus 3 halves x. Well, then you'd have to get the x out of the logarithm by exponentiating with base 10 to undo that log to get x plus 3. But then you end up with x in the exponent. You've got 10 to this expression involving x. And now it's like, oh, well, how do we get that out of the exponent? So there's just no way to solve it algebraically. So we go to the calculator and type it in. Here I've already typed in the line, the linear equation solved for x, or sorry, solved for y. If you subtract the x term from both sides and divide everything by -2. You can just type it in as -3x plus 6 or 6 minus 3x all over -2. So that's what I have here, 6 minus 3x all over -2. So this is the graph of that intersection point down here where I have stretched out the x-axis. Check this out. The window goes just on either side of the asymptote at -3. So then you can see that they actually do cross. Now I tried intersect for that one. If you go second calc, intersect, enter, 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 it actually approximates it as -3, -7.5. So that's this point down here, -3, -7.5. Approximately. It's actually just ever so slightly before -3, like -2.9999999 something, but it rounds to -3. So again, that's an approximation for the intersection point. This one up here, you just go back to a standard window, zoom 6, and that one's easy to see and easy to find by going to second calc, option 5, enter for first curve, enter for second curve, enter for the guess, and there it is, 2.49 for x and 0.74 rounded for y. So this one, yeah, 2.49, and this is the one that's in the answer key for this. They don't give you this one down here for some reason. So that's solving a system by graphing. You just graph and use intersect. Normally they don't have such obscure intersection points as this one does. So if it does, just find the obvious one. You should be good. All right. Now for the systems of inequalities. Here we have number 70 is y is less than or equal to x plus 2 squared minus 1, and 2x plus 3y is greater than 6. All right, so what we want to do is graph and shade. So what you want to notice here is that this is going to be a solid curve, and in fact it's a variation of a parabola, the squaring function. So it's a solid parabola, and it's solved for y, and we have y less than. It's solid, by the way, because of the equals being included. And less than means we're going to shade below. All right, so let's graph that. So we have a parabola that is shifted to the left 2 and down 1. Left 2, down 1. There's its vertex. Otherwise, you've just got your generic squaring function. You could plot the y-intercept if you want. If you plug in 0 for x, you get 4 minus 1, which is 3. So it actually hits the y-axis there at 3. And then, of course, has a mirror image point over there. All right, this one is a line. That's a linear equation if you look at the equals, the boundary. But this is going to be a dotted line because it does not include equals. And greater than, if you solve this for y, 3y is greater than -2x plus 6. Dividing by 3 maintains the inequality in that direction. Remember, if you divide by a negative number, it turns the inequality around. But this one stays greater than, so that means we're going to shade above it. All right, so here we have the line with y-intercept 2 and slope -2/3. So down 2 over 3 gives us another point, or up 2 and to the left 3 gives you another point. So we've got this dotted line here, crosses the parabola right here. And we want to shade above the line, but below the parabola. All right, so let me extend this. Below the parabola is going to be outside of the parabola, and above the line is going to be, above. So it looks like we're going to be shading there and here. So that's your solution. It's also good if you can find the intersection points to label those, sometimes called corner points. And that's, of course, where you could use your calculator, or you could solve the system, setting those equal or substituting to get those intersection points. But we'll just let that go for now. On the final exam, they are not going to require that you label intersection points for your system. I guess they figure you're going to have enough to do. All right, let's look at number 72. See if I can wake up my computer here. Number 72, or 71, excuse me, is x squared plus y squared is less than or equal to 25, and x plus y is less than 5. All right, so for that one, you want to notice that this is a circle. You've got, let's see, a circle with center at the origin and radius equal to 5. Again, hopefully you've got the equation of a circle memorized. So you go out here 5 units in each direction and plot a point, and then this is going to be a solid circle, yeah, because it includes equals. So that's going to look something like this. And then this is a line. Notice that these are very different inequalities. For example, you can't just take square roots of terms that are added or subtracted. This is a line. It has a strict inequality, so it's going to be dotted. And we're going to shade below. Now the circle, you actually have to test a point. That doesn't mean below, because a circle really just has an inside and outside, not a below and above. So you have to actually test a point, and 0, 0 is the easiest point to test. And you'll see that this makes a true statement. So that means that we want to shade the inside of the circle, because that's the part of the circle that includes the origin, the point 0, 0. All right, this line, if you solve that for y, you get y is less than negative x plus 5. So that has y-intercept 5. So they share a point right there, and slope negative 1. So it's going to go down 1 over 1 and eventually hit the x-axis right there at that other point. And oops, this one's supposed to be dotted. So we have the solid circle and the dotted line. And then we want to shade below that line and inside the circle. So actually it's good that I erased the part I had shaded that's above the line. So inside the circle and below the line is the solution region. All right, that was 71. Sorry about that. So eager to be done, right? 72, yay, last one. We've got 2 linear inequalities. Y is greater than 2x minus 1, and y is less than or equal to negative 1/2 x plus 4. All right, so they are nicely solved for y. This one is going to be a dotted line, and we're going to shade above. And this one is going to be a solid line, and we're going to shade below. All right, we can use slope and y-intercept to graph these. So the first line has a y-intercept at -1 and a slope of 2, so up 2 over 1 gives us another point. And the other line has a y-intercept of 4 and a slope of -1/2, so down 1 over 2. Oh, down 1 over 2. Actually, I think that hits that line, doesn't it? If we go down 1 over 2, yep. This is up 2 over 1, up 2 over 1, yep. They have that point in common. This one is a nice solid line. The intersection point is 2, 3. We want to shade above the dotted line and below the solid line, so that'll be this region right here. And there's your solution. The end. Good luck on your final.